In part one of this series, I shared my list of hallmarks that activities must have in order to develop or to foster number sense. Then in part two of this series, I explored several exemplar activities that provided open input. In this episode, we're going to explore activities that foster multiple models of number. For decades now, I've been saying that one of the best ways to develop flexible thinking and therefore number sense is to give children the opportunities to see numbers as quantities rather than symbols. And we need to give them experiences manipulating quantities that they can decompose and then recompose so they develop a strong, large repertoire of computation strategies as they get older. I love showing this example of how to find the answer to a fact that makes use of a double. Here I want students to show me 4 and 6 with materials. Then we move 1 from the 6 over to the 4 to make double 5. So when they see 4 and 6, they know it is just double 5. Now traditionally, you would try to remember that 4 and 6 is 10. But if your concept of these numbers goes beyond symbols to quantities, then you know you can decompose and recompose them in equivalent ways. I suspect if you were educated in the 70s, 80s or 90s, you were never given the opportunity to think about numbers in this way. And sadly, many students today are not given that opportunity either, as teachers actually fall back on the way they learn mathematics when they're not given sufficient support to teach differently. So in the early years, use activities or games that involve quantities rather than symbols. Try working with a group of students using standard dot cubes from 1 to 6. Roll the cubes and ask them how they would find the total of all three numbers. For example, suppose they roll 2, 1 and 3. They might simply add them in that order. But with practice, as they see quantities, I've heard students say, I'll just put that 1 there and double 3. Notice a subtle difference between those two approaches. That is, counting them in the order they see, 2, 1 and 3, or actually moving a dot over to the 2 to make a 3. They dealt with the numbers in the same order, but the second student did only one calculation as they visualized the arrangement of 3 first. Suppose the next roll is 5, 4 and 5. They might add them inefficiently in the order in which they appear, or they might add the 2 5s, then the 4. But because they are seeing quantities rather than symbols, they might say that if I add 1 dot to the 4, that makes 15. So the sum must be 1 less, that's 14. So you don't often think that way using symbols. Activities like this will help young students progress from simple count-all strategies to more efficient strategies involving, say, doubles or making a 10 when they're adding 3 digits. Now, to consolidate this idea, I've given you a free game in the links below. Imagine you have $89 in your wallet and the item you want to buy costs $105. How much more money do I need to buy that item? Now you could use the traditional algorithm to solve this problem, but it's quite difficult because the price has 0 in the tens place. Some people might start with 89 in their head and simply count up in comfortable steps like this. Others would simply know the position of 89 relative to 100. It is 11 away. Then they would add 5 more to calculate that the difference is 16. The idea of relative position is used heavily when we compute mentally, so we really need to do more with this model of number in our classrooms. Look at this activity, for example. If the arrow is pointing to 50, where do you think these numbers are located? In other words, what's the relative position of 100 to 50? Or 25 to 50? Number lines are key here. You don't see relative position using base 10 blocks. And here's a slightly different activity. What numbers could be located at points A, B, C, D, and E? To find the numbers that match each point, students will need to use relative position. For example, they might determine that B is 10 and D is 11, and to think to themselves, what is the position of C relative to 10 and 11? Well, it is halfway. The number one resource for developing place value is base 10 blocks. They've been around for decades, and I've been around for decades too, and I've seen companies come and go as they try and put a simple little twist on this basic resource, and it really just isn't needed. It works well. So I'm not going to show you activities involving base 10 blocks. I'm sure you have many. But I will say you can use freely available resources as long as your language matches the resource or model that you're showing. Let's look at an example. Let's look at the hundreds board. I'm using a reverse hundreds board here, so my language of counting up matches my actions on the board. Ask your students to use the board to figure out 35 plus 23. They might start by placing a counter on 35. If so, ask why is that 35? As this model is rarely used to talk about place value, I even find that teachers struggle to give me the answer that I want to this question. It is 35 because it is 3 rows of 10 and 5 ones. Then to add 23, the student could count 23 ones like this, but this is unlikely. They are more likely to add 20 by counting up 1, 2 tens, then adding 3 ones. Did you notice my language? I intentionally said counting up because it matched my actions of moving up the board. And I also was very intentional about referring to 2 tens of that second add end, rather than just the 2, which could be perceived as being 21s. Now, if your students have not yet encountered a reverse hundreds board like this one, you might still want to use a traditional hundreds board. Here is a chunk of a hundreds chart, and here are some pieces of that same chart. Write the numbers that belong at A, B, C, D, and E. Now, activities like this require students to use their understanding of place value. Now, similarly, you can use a number line to develop this idea of place value. You just have to make sure that your language matches that model so it stresses the idea of tens and ones. Take a look at this number line. What number is positioned here, and how do you know? Most adults and children will tell you they know it's 35 because it's halfway between 30 and 40. Now, while this language of relative position is both good and accurate, this model also allows you to say that I know it's 35 because it's 3 jumps of 10 and 5 more ones. So this is what I want you to do. 1. Look for games and activities that help students think flexibly about numbers and to see them as something much more than just symbols. So use number in situations where they are seen as quantities, as relative position, and as place value. And 2, if you teach young students, use the game I provided in the link to help them see number as quantity. And finally, if you've seen value in this episode, please give me a thumbs up, share it, and subscribe today so you never miss another learning opportunity with me. See you next time.